So here mean error is simply the sum of the errors, okay, from 1993 January, okay, through 2005 December. So that's just this sum. Okay. Now MSE is MSE actual values 1993 January through 2005 December, comma, okay. The forecast is in column E, so that will be E32 through E187. So that will give us MSE. And we can do MAE and RMSE in the same fashion. Okay, so MAE and RMSE. Okay, now for MASE and Thiel's U, so we have to give three ranges, remember. The first two is same like the others. So you start from 1993 January through 2005 December, okay, comma, then E32 through E187, okay. Now we have to give the naive model forecast range. So remember, naive model in the case of seasonal data is not just one period before, but it is one entire cycle before. So the forecast for 1993 through 2005 will be the actual values from 1992 January through 2004 December. So you should be careful how you use the baseline data range for computing MASE. So that would be the MASE, and same range for Thiel's U. Okay, so same range, so that gives you the value of Thiel's U. All right. So now we have the error measures set up for the estimation sample. Now we can run the solver. Okay, here, say let's say we want to minimize RMSE, and gamma is the changing cell, and gamma must be less than or equal to 1. Okay, non-negative, GRG non-linear, and you run, and you get the optimal gamma value. Now we can estimate what the error measures will be for the holdout sample with this estimate of gamma equal to 0.177. Okay, now let's suppose we want these measures for three different gamma values. One is the optimum value that we just developed. The second value for which we want the error measures is gamma equal to 1. So in which case it is simply the naive method, which is forecast for a given time period, is the actual value of the same season in the previous cycle. And gamma is 0, which means we're going to use the same forecast as the initial forecast, just repeated as forecast year after year, no change. The same set of 12 forecasts will be repeated as forecast for every other period. Okay, now we want the error measures for the holdout sample. So ME is the sum of the errors starting from 2006 and all the way to the end. So we have to go back down to 2000, end of 2005, and start with 2006 and go all the way to the end. So that's our ME for the holdout sample, F188 through F220. Then MSE is MSE of the holdout sample actual values D188 through D220. Those are the actual values, and the forecast is in column E. So E188 and E through ET220. Okay. Now use the same range. Okay. And instead of MSE, so we'll have MAE and RMSE. So that's our MAE and RMSE. Now with the same range for MASE, okay, so this is our actual set of values. This is our forecast. Now we have to give the naive forecast range, which is the actual values but one full cycle ahead. So we have to start 12 periods. So we have to start from January 2005 through the December of 2007. So that will be D176, that is January of 2005, and will go all the way till 2007 December. Okay, the naive forecast range is D176 through D208, January of 2005 through December of 2007. Okay. Now the same range for Thiel-Zio. Okay, so understand the naive forecast range in seasonality case, because it's different from what we used in chapter 3. Okay, so now we have set up the margins of the data table. Now we can run data table for this table with input values for gamma coming from this first column and gamma going into, so that's our input cell. So we go to data table. Now gamma is in a column, so enter that, and now we get the values for the holdout sample. These are the values for the holdout sample, and as you can see, holdout sample does slightly poorer than the estimate sample. And if you look at Thiel-Zio, looks like gamma of 0.177 definitely beats the naive approach. So this is definitely going to give you a better forecast than the naive method. So this is our SES approach. Here we are not taking trend into account, because as we saw in the graph, there is no trend. It's pretty much bunched together. Year after year, the temperature is not moving up or down, but there is seasonal variation. So this SES method is good for pure seasonality, no trend.